Alrighty, we want to simplify the radicals in the square roots below. So let's start with square root of 36. You always take the prime factorization of the radicand. So if we do the prime factorization of 36, we get square root of 2 times 2 times 3 times 3. And we have two squares in here that we can pull out. We have 2 squared times 3 squared. So the square root of 2 squared is the same as 2, and the square root of 3 squared is the same as 3. When we pull these out as the coefficients, we're going to multiply them together, and that gives us the square root of 36 equals 6. Let's try that again with 3 root 12. 3 root 12 turns into 3 root, and the prime factorization of 12 is 2 times 2 times 3. Remember, our index here is understood 2, so we're going to look for powers of 2 in here. We've got 2 squared, and if you pull 2 squared out, you'll multiply it by the coefficient that's already out there, and this gives us 2 times 3, which is 6 as the coefficient, and we have a 3 remaining as the radicand. And then finally, let's try simplifying 2 times the cube root of 125. So if you take the prime factorization of 125, you get cube root of 5 times 5 times 5, and don't forget about the coefficient 2 at the beginning, that stays there. And now this time we're not looking for squares within our prime factorization, we're looking for cubes within our prime factorization. We have a cube right here, this is 5 cubed. So the cube root of 5 cubed is simply 5, and we multiply that by our pre-existing coefficient. So we get 2 times 5, which tells us that 2 times the cube root of 125 is 2 times 5, which is 10. And we can use this process to simplify radicands to have like radical terms when we are adding and subtracting radicals.